this screencast is going to talk about graphing logs. Now, we've talked about exponential and log functions, and we've discussed how they're inverses of one another. An exponential function is the inverse of what would start as a log function, and a log function would be the inverse of what would start as an exponential function. So it shows both of these functions here in the blue and red. So the one we're going to be focusing on is the red, because that's the log function. So it shows you the parent graph, and it says the graph of log base b of x is shown for when b is greater than 1 and when b is between 0 and 1. So because log base b of x and your exponential function b to the power of x are inverse functions, it shows that they're a reflection over that diagonal line. So what happens, guys, is that your exponential functions, which is the only graph you've looked at so far, have horizontal asymptotes. Log functions have vertical asymptotes. So they run along this vertical imaginary line. So what happens when you guys graph logs, there's never going to be anything to the left-hand side of that asymptote, wherever it may be. It could be to the left or right of the origin, but wherever it does end up being, there's never going to be anything on the left-hand side of it. So that's what that piece says down there at the bottom. So because of that vertical asymptote, that's going to affect your domain of your function. So one more time, because they're inverses, what's going to happen for your log functions is your domain is always going to be whatever your vertical asymptote is to positive infinity, because it's always going to be to the right of that vertical asymptote. And your range is always going to be negative to positive infinity for these. And that's always going to be the case here. And that makes sense, because for your exponential functions, it was the domain that was negative to positive, and these are inverses, so that means the range is going to be. But that will always be the case here for your range. Always negative to positive infinity. So if we were asked to find the vertical asymptote of a function, all you're looking at here is what's on the inside of the parentheses. So sometimes you guys may have something that's log base b of x minus 4 plus 2 or minus 7, but all we care about is what's on the inside of the parentheses. So if we look at number 1 and number 2, what happens is we take that part that's in the parentheses and we solve for it for 0. So here, if we solved for x minus 4 equals 0, we would add the 4 over, and x would be at positive 4. So if you guys graph this, and again, this would be a rough graph, but your vertical asymptote should be somewhere over here at 4, and that would be something like your function. So your domain would be from 4 to positive infinity. So your vertical asymptote would be at x equals 4. So if we look at number 2, we would do the same thing again. What's inside the parentheses? 5 minus 2x. Set it equal to 0. Subtract the 5 over. And divide by negative 2. So at 2.5. So your vertical asymptote would be at x equals 2.5 or 5 halves. So your domain would be from that value to positive infinity. And remember, guys, I just put a bracket, but remember, your vertical asymptote, horizontal asymptote, asymptotes in general are values that your graph's approaching or trying to reach. So we don't actually ever reach that value of 2.5 or positive 4 in the first example. So they always get parentheses when you're talking about the domain here. And infinities just always get parentheses. So go ahead and try the other two. So you're finding the vertical asymptote and then stating the domain.